Hello everyone, and welcome back. So this time we're solving for the force DE. Oop, no pin. There it is. Right here. It's a little bit harder problem because, as you can kind of see, this is no longer symmetric. There's a whole lot of different forces that are acting on this. But the setup is the same. One other thing is it notes that this is a rolling support, even though it's not drawn that way. Not a fixed support. It's actually unable to be solved otherwise. So what is the internal force in member DE in kips? Well, let's solve that. So the first thing we do is draw a free body diagram. Okay. And I need to solve for these. So I'm going to say this is AY, this is AX, this one right here, this is DY. Okay, so I have some of the forces, the X I can use, and so that would be equal to, let's see, we have AX plus 10 equals 0. Therefore, AX equals negative 10. Okay, so I actually drew this arrow in the wrong direction then. That's okay. 10. Then sum of the forces in the Y is equal to 0. And that will be equal to AY plus 50. Oop. Careful with your minus signs. Minus 15 minus 15. And then finally, plus dy. Now this is not symmetric, so these forces aren't going to be the same this time. And so what I get is that ay plus dy is equal to 30. And finally, sum of the moments. I'm going to choose around A. I'll choose a point that has an unknown. And that gives me 15 kips times 12. 15 times 12. And that is going clockwise. So clockwise will be positive. Plus 15 times 24 minus dy times 36, and then don't forget this force right here. So that's a distance of 9 feet. So, and that one is still going clockwise though, so plus 9 times 10. Okay. And if I solve for that, let's see what I get. Plug in my calculator now. So 15 times 12 plus 15 times 24 plus 90, that's 10 times 9. I divide all of that by 36. Comes out to be 17.5. Okay, that seems reasonable. That seems reasonable. So therefore, dy equals 17.5 kip. And ay equals 12.5 kip. Okay, so let's put our numbers in and we'll keep on going. Now to solve this problem, I'm actually going to use method of joint instead of method of sections. Fairly small truss. I could use either one. Both are possible, but not necessary. Actually, method of sections would give you less equations to solve. I'll show it to you both ways. And show you why you might want to do one versus the other. And what am I doing again? Ah, yes, I'm actually placing my numbers. So 17.5 here, 12.5 there. Okay, I'll show you method of joints first. So I want the force in DE. And so what I do is I pick this force right there. I'm going to pick that joint. Now redraw it. This is a new free body diagram, and since it's a point, I get two equations that I can use. So that would be 17.5 here, and then this would be force DE, which is unknown, and force DC, which is also unknown, but two equations, two unknowns I can solve. So the first one I'll do is the sum of the forces in the Y. I'm doing this because I'm your omniscient teacher and I know what to do in here. And this guy right here has a slope triangle of 4 on the bottom, 3 on the side, and 5 here. We're using that for my components. So it's going to be equal to 0, and it's going to be equal to FDC times the vertical component, so the 3 here, over the 5, plus 17.5. As you can see, I have a little bit of an issue here, in that I drew my force in the wrong direction. That's okay though. So FDC is going to be equal to 17.5 times 5 over 3. Okay, now let's look at this right here and see what it comes out to be. My handy dandy calculator, which is not open. Open it up again. Okay, so 17.5 times 5 divided by 3. 29.16 repeating. Okay. We'll just stop there. Now I do some of the forces in the X. The reason I did this some of the forces in the Y first is because I only had one unknown. I was able to solve it instantly. And I was able to avoid algebra by doing that. Okay, so forces in the X is going to be equal to FDE minus, remember, this is drawn in the wrong direction, (29.16), and we're using the horizontal component this time, so times 4 over 5. That's going to equal 0. So FDE will equal to 23.33 repeating. Okay, and that should be your answer. Okay, so pause it here if you need more time to write down this work, because I'm going to erase what we just did, all this, so I can make some room to show you how I could have done it with method of sections. So it's all gone now. This is a video, so you can have as much time as you need to write things down. Okay. And now I'm going to do it with method of sections, even though it's a very small truss, and method of joints works very well. And I'll show you why, because I can actually solve it with just one equation of method of sections. So I want to cut right here. Excuse me. And when I do method of sections, I can't actually keep this side because that side is just adjoined. So I have to keep the other side. You think, well, that's a lot more drawing. It is a lot more drawing, but it's actually a lot less work. Now, let's see why here. Okay, so I do my new drawing. Okay, this is the point right here. We go like this. We have a force. We have a force. Going down. We have a force. Over. Maybe a bit of drawing work, but not too much else. Okay, that's 10. That's 10. That's 12.5. 15. 15. We have two forces we don't really care about, which are force CD, which we solved for last time. Oh, there's not even one right here. I was just drawing it incorrectly. Okay, and we have this unknown, which you do care about, force DE. Now, if you look at this, There's two unknowns. I only care about one of them. So I'll just take the sum of the moments right here. Second thing, this doesn't have a component there, but this doesn't either. And neither does this one. Reason? Because their lines of action all go through that point. Therefore, only these three forces and this one cause a moment around that point. So it's one equation to solve the problem. Sum of the moments around point C, I believe is what that one is. It's going to be equal to, I'll choose FDE first, so FDE times 9. And then I keep on going. So distance times force. Distance times force. And then we're going to have this one right here, which is, let's see, that one will also be positive as I've drawn it. So plus 12 times 15, because they're both causing it to turn counterclockwise. And I have this guy right here. So let's, okay, a little check mark next to make sure I know I've done it. And I have this force, and that's going to be causing a clockwise turn, so it's negative. 3 times the distance of 24. And the final guy causing a clockwise turn, so minus 10 times 9. Okay. And if I solve this, I'll go ahead and plug it in my calculator, make sure it comes out the same. Which if it doesn't, I've done something wrong with my algebra. Which, as you all know, never happens. Plug it in now. And I get 23.33. So, it's nice when math works. That's going to be tips. Okay. So with this, I showed you how you can solve with both method of joints and method of sections. I really hope this helps you, and I will see all of you next time. Have a good day.